Hello everyone, welcome back. So let us start without wasting any time with derivation of kinetic equations of motion with the help of calculus method. So let us see. As you all know that there are three equations of motion. What are they? Let us see one by one. The first one is v is equal to u plus at. The second one s equal to ut plus half at square. Third one v square is equal to u square plus 2as. Here the terms have the same meaning as you know well. V is final velocity, u is initial velocity, a is acceleration and t is time. Where here in case of s it is displacement. So all the terms are very clear to you. Once again I am telling you, u is initial velocity, v final velocity, then a acceleration, s displacement, and the final one t stands for time. Alright, these are the three equations of motion. Now I shall try to derive all these three equations of motion and with the help of calculus method. Keep in mind, while solving calculus method, here we have to remember one formula of integration, that is x to power n dx is equal to x to power n plus 1 divided by n plus 1. Keep in mind the limit a to b, then it is very simple for you. Once you have to put here b and the other time you have to put here a. So the answer will be like this: b to power n plus n minus a to power n plus 1 divided by n plus 1. I hope it is clear to you. This will be the different integral of x to power n dx. One more thing, that if it is simply dx, so your answer will be x, right? Suppose if it is from a to b, then here it will be a to b and answer will be b minus a. I hope these two formulas are very clear to you. Next two formula that we are going to use in the derivation, that is acceleration is equal to dv by dt, and one more thing, velocity is equal to dx by dt. I hope that you know about this differential equation very well. So let us start. We know that by definition it is very clear to we all that acceleration is rate of change of velocity per unit time. We can also write it like this: dv is equal to a dt. Now if we integrate it both the sides, if we go on integrating both the sides, then here we will integrate from initial velocity to final velocity dv, and here it will come a from time 0 to time t, that is dt. Now you can use very simple formula: dv, v and u is here. Here it is dx, x b to a, that is b minus a. Simply if it is dx a to b, you can simply write b minus a. So it is dv vu, so you can simply write v minus u, and here you will be getting a. Again here t minus 0, it will come t. Finally equations come to be v is equal to u plus at. This is the first equation of motion that we have to derive. Alright, let us go for the second equation of motion that we have to derive, and for that we will be using v is equal to dx by dt. So let us see. Very simple. Now by definition we know that v is equal to dx by dt, and again here it will be dx equal to v dt. It is very simple to integrate both the sides, and I know now you will be integrating it. Okay, integrating both the sides, what will be getting? See here, if we try to integrate it, here we will integrate from initial point to final point, okay, dx. And here for v you can write, for v what can you write, u plus at, okay. Here it is dt times 0 to t. Now I am just making it simple for you. Here we can directly write x final minus x initial. It is very clear to you. And next one, what we will write here, see that u, and we can just separate it out. It will be u dt and then plus 0 to t, and here at dt. I hope this is very clear to you that plus sign will be separating here integrals. So for u dt, u is constant, initial velocity is constant. For that, constant will be taken out. And for dt, we will simply write t. X final minus x initial, this is displacement. And here comes u into t, u is constant, and then plus. Here you will get a is constant because the equation of motion that we are deriving, that is for uniformly accelerated motion, okay. So here acceleration is constant. Now t is left, t into dt, formula will be used, x to power n dx. Power is 1, so you will be getting t square by 2, okay, from 0 to t. One time you put here t, other time you will put 0. What answer you will be getting? You all know well that finally displacement will be equal to ut plus half at square. So this is the second kinetic equation of motion. I hope it is clear to you. So note it down. The next one we shall be deriving third equation of motion. Further, we know what, that acceleration is equal to dv by dt. But this can also be written like this, dv by dx into dx by dt. Okay, is that clear? Dx and dx will cancel out, so again we will get dv by dt, dividing and multiplying the same coefficients, no problem. Now this is dv by dx, while this dx by dt can be written as v for, that is velocity, because dx by dt is velocity. So again here you can write a into dx and it will be v into dv. Now it is going to be simple for you, very simple. See here, integrating both the sides, I am simply writing integrate, okay, simply writing here, I am simply writing here integrate. Let us see, it is integral from x initial to x final, a is constant, so for dx, and here u to v, we will integrate initial velocity to final velocity, v dv. Now here you will be getting x final minus x initial, and here you are getting v square by 2. Upper limit is v, lower limit is u. One time you will put here v, other time minus, then u. Then what will be the answer here? This is actually displacement, so a into s, and here v square by 2 minus u square by 2. Denominator is 2, very simple. I am taking this calculation over here. Just see, as is equal to v square minus u square divided by 2, and you will get 2as is equal to v square minus u square, and finally you will be getting the equation v square is equal to u square plus 2as. Okay, these are the kinematic equation of motion and its derivation using calculus method. Now we are here on the last topic that is left for discussion, that is relative velocity. So we shall try to cover it up today itself. Let us see. What is relative velocity? To understand this concept, first of all, we have to see in our surrounding that what happens when two objects passes by, or when we are traveling and somebody overtakes us, or sometimes we overtakes other person's vehicle. What happens at that time? See here, whenever on road we are traveling, suppose we are traveling by a bus, okay, and another bus overtakes the bus in which we are sitting. At that time what will happen? I think the bus which is overtaking, that will seem slower to you, but not to the person who is standing on the road, okay. For the person standing on the road, both the buses are moving in speed, but for you the bus which overtakes, that will seem slower, because at that time you are also in motion, as well as the bus which is overtaking you, that is also in motion. So in this case, here we will take one factor in account, that is frame of reference, that is rest frame. Means if you are moving and other body is also moving, at that time the velocity that is common in between you, that will be taken as rest frame, or that will be taken in rest. Now the excess velocity, if anybody is having, that will be the relative velocity. So here, suppose if there are two objects moving with two different velocity, consider it v1 and v2. v1 and v2. Now if I have to find relative velocity of object 1 with respect to object 2, then it will be v1 minus v2. And if I have to find relative velocity of object 2 with respect to 1, then that will be v2 minus v1. Okay. So here it is nothing, simply comparison of the velocities of the two moving objects. It's very simple. Suppose if you are moving with 10 meter per second and the other object just beside you moving with 15 meter per second, at that time relative velocity of that object with respect to you will be 5 meter per second, because that body is moving 5 meter per second ahead of you, and your relative velocity will be negative 5 meter per second, because you are moving backward to that body or slower than that body with the difference of 5 meter per second. So this is simple concept of relative velocity. Let us see few graphs related to it. Position time graph for relative velocities of two objects. Suppose if two objects are moving with same velocity, at that time their graph will be parallel to each other. Okay, their graph will be parallel to each other. Next, suppose if two objects are just having difference in their velocity, at that time what will be happening here? Just I'm going to explain you. See, suppose one is this one, another this one. Here the point of intersection. Okay, so let us see. This is the objects with unequal velocity, and here we are getting a time of meeting. Okay, this is the time of meeting of the objects. Here we are showing the position. All right. See, you can consider from these two that yes, the velocity of, suppose this is object B and this is object A, so the velocity of object B is higher than that of object A. While in this case, when the objects are moving parallel, at that time, or you can say when the graph is parallel, at that time actually both the objects having relative velocity 0. Okay, that means they have equal velocities. Now if the two bodies are moving in opposite direction, then what will happen? This is the case when the two bodies are moving in same direction. When they will be moving in opposite direction, a graph will be coming just in the negative direction. It is as simple as I have explained you in position time graph. And in case of velocity time graph of negative direction with negative acceleration, already we have discussed that thing. Okay, so this is a very little bit explanation, a brief explanation of the relative velocity. If you have any kind of doubt, any kind of just problems are being faced by you people, so just mention it down in comment section, and we will be discussing all those doubts in another video lecture, or maybe on WhatsApp group. Soon I will be providing you my WhatsApp number also. So alright, thank you.